Okay, so we are going to be going through the steps to condition a 3D asset for import into a game engine. And this is going to require separating it out from its combined fellow 3D assets here. Some asset cleanup. We need to look at the topology. I can tell from the curvature of this asset, it's going to have a lot more polygons than it initially appears to have. Which is not actually a huge deal with Unreal Engine's non-destructive reduction tools, but it is something we have to keep in mind as we're moving forward, as well as set up material IDs, etc., etc. So this asset is part of a abstract 3D shapes pack by Doodle99 from TurboSquid. And the first step, of course, is to separate it out and make it distinct. Now, Maya users will have experience with this. I'm not sure if it's going to be the same with other 3D packages, but quite often when you have a lot of geometry and very complex assets like this, running a separation operation, so if I just went, say, mesh separate, could hang my PC for hours with absolutely no effect and never actually finish the operation. So another method you can do for separating out assets is a little bit hokey, but you just, so I'm going to hide this mesh. I'm going to duplicate it, and I'm duplicating it while it's hidden because I don't want to basically have the double amount of polygons taking over my available virtual memory and crashing my computer. So what I'm going to do is I am going to select just this asset. I could do it with, say, a selection tool and try and then deselect all the other faces, etc. But I find the quickest way sometimes is just to go to UV shell. And if it has UVs, which it may not, you can just select by shell. It doesn't look like it actually has UVs. So I'm going to go to front view. Nope. Let's go to right view. There we are. And I will use the selection set in this case. But if this had UVs, you can easily just grab by UV shell, and that would make the selection process significantly easier. Instead, we should also switch back to faces. So let's grab just those faces. And again, I could try and do an extract operation, etc., but that would also most likely hang up my computer. So instead, what I'm going to do, because remember, this is a duplicate. We've got the original there. I'm going to hold down Shift and select across the whole thing. And what that should do is invert my selection. And now I'll just delete that. A single solitary mesh. Let's go back to perspective view. And first thing we're going to do is I like to delete history after every major surgical procedure. I'm going to go center pivot. So I've got my pivot option available to me, and I'm going to hold down X on my keyboard, left click, drag this to the center of my world space here. And I've got these translations on this. Now, if I export with translations, it is going to import incorrectly. So I want to freeze my transforms so that at world space 0, it is sitting at 0, 0, 0. And if I move it, whatever the translation is true to world space. It is not it's not a lie. Okay, so that was just separating out the mesh, making it distinct, and let's try that one again. Okay, so that was just separating out the mesh. We still need to do a little bit of mesh cleanup just to make sure that what we're bringing into Unreal is as clean as can be. Okay, so there's a few things I like to do before taking a mesh into Unreal, or any game engine for that matter. One is a hokey old trick I learned from a brilliant environment artist I used to work with named Matt Barker, who showed me this years ago, and it has solved so many problems. I am creating a cube. I am going to combine these two meshes. This seems very strange at first, but trust me, just go with it. And then I'm going to delete the faces on that cube that I just created. And what this does, so you'll notice that now it's called P-Cube, which I, of course, have to rename. But what this does is it effectively rewrites the code of the mesh. So the back end of this mesh is the back end of our original cube. And it has inherited this geometry, but it's got its own new fresh backend. And we're not going to be taking any code that was generated by Blender or whatever the other content creation software was with us into Unreal. So I'm just going to call this abstract A1 or A2, abstract A2 for that matter. Okay, so that's the first one. Second thing we're going to do is we're going to put a brand new material on this. So let's go assign new material, just drop a Lambert on that. By giving it a fresh material, again, same thing. We're not bringing in any junk code. And I'm also going to give it some fresh UVs. I'll just do a quick automatic map. Okay, so it now has UVs, of which it did not have before. And I am, of course, going to want to delete history on that because it now has this poly auto project on it. And when we export it, we would like to have no history whatsoever. I'm going to be doing a few more things, but it's just good practice to be deleting history as you go. Okay, so we've given it a new polygonal backend. We've given it some UVs. Let's also now make sure that it's just going to be rendering correctly. So a couple of things that we can do to just make sure that on average, it's going to, pretty sure it's going to render correctly. We can go up to Mesh Display and Set to Face, which is going to take a moment. Okay, so that took a hot second. So what Set to Face does is it basically crawls around the mesh and just reorders the direction that the normals of each face are facing to the direction that face is facing, as opposed to what can often happen in 3D programs where the face that we see, which is facing out in a perfectly logical fashion, has a normal that's pointed in some other totally random direction for no good reason. And Set to Face just kind of goes through and removes that as a problem. Now, the next thing we're going to do, because obviously when I've done Set to Face, it has created this faceted shading on the mesh. And that's because now, each face is kind of going, well, I know my job and I don't really care about what the next guy's doing. What we want to do is say, well, if I'm on an edge, sure, I should have a hard edge. But if I'm one face holding the line with a bunch of other faces, then we should have a smooth transition. And that next tool is going to be Soften Harden Edges. So I'll go Soften Harden Edges and I'll click on the options box. Now at default, it's 30%. I think 30% is a pretty good one to start with. Let's just go ahead and hit apply and close, and let's just take a look. And voila, it's a bit funky. I think maybe we can do that again with a slightly higher value, but you can see how it's now got harder edges on the outside and softer on the inside. And in some cases, you can just go with a straight up soften edge or harden edge, depending on what your object requires. I think the organic curvature of this mesh is demanding mostly soft edges, but I am getting some very strange artifacts up here. One solution is, of course, to add some more geometry, but that is beyond the scope of this particular video. But if I were spending more time on this, I could just run a smooth on this, but then I'd have to go reduce it on the Unreal side, or I would add lines of edges where I need to have smoother geometry. Okay, so we've deleted our history. Our world space 0 is at 0. We've got a center. The pivot is where I would like to move this around at the center, but if this were, say, a window or something, I would want to make sure that the pivot point is at the corner, and then again, snap it to world space 0. I am ready to export this. So I'm going to go, before I export, I just want to make sure my material IDs are set up correctly. So let's See how now we've got our cool little funky UV shells. I'm just going to grab a couple. I just want to have a couple different materials on this for the sake of showing off material IDs. So I'm just going to grab some shells. And when you're using when you're jumping between Maya and Unreal Engine a lot, you will find yourself constantly switching keyboard layouts because of the hotkeys you're using. That's fun. Okay, so I've grabbed a bunch of UV shells and I'm just going to add a different material to that. And because I just want 2 different material IDs on this so you can see what happens. Now I'm going to name this. It's important to name your materials before export because that's going to name your material ID slot. So I'm just going to go M for material, and I will call this 1. And the other material, which is the first Lambert we applied, I'll just call this M2. So I've got material ID slot 1 and slot 2. Now I am ready to export. So I'll go to File and Game Exporter. Now, of course, there are other export options, but Game Exporter I've just found to have the most consistently clean result when it comes to exporting to Unreal Engine. So I'm in Model Default. I'm going to change it to Export Selection because I don't need to be exporting my camera or any of that business. And I'm going to leave Triangulate off for now. It will triangulate on its own when it goes into Unreal Engine because that's just what engines do. Now, I would, however, like if I were, again, spending more time on this, for example, adding in the extra edges so that we don't have that dark artifact on the edge, I would actually triangulate this in Maya because I want to be sure that the triangulation is going to render the way I want it to render. So it's worth it sometimes to just have ownership over what's going to happen to the mesh before you send it into the engine. I've got input connections and embedded media on because again, I want my material IDs and everything to come through as well as my UVs, etc. Under file type, FBX version, FBX 2018. Again, it's just giving me the most consistently good results. So I generally stick with that. Up axis Y. Okay, and now we choose an export directory to send this into. So I'll just go up a bit, grab my conditioning folder. There's my abstract geo. I used to separate all my stages into different folders, and now I just try and keep everything associated with an asset in one place because hopping and skipping across directories is boring. So I'll just call this static mesh abstract A2. Right. Let's cut that. I'm just selecting the directory, not actually naming it yet. So that goes into where it says enter a file name. I'll hit export. Export successful. Let's hop over to Unreal Engine and make sure that that comes through clean, and I'll show off how the material IDs work. Okay, we are back in Unreal Engine, and let's bring in the skeletal meshes that we had just exported. We'll start with the SM abstract A2. And I want to go through some import settings. I'm just going to reset this to default so that it looks a bit like what you might be looking at. And I'll show you what it is that I change. So first off, I'm actually going to turn off generate missing collision. So especially if you're going into UEFN or if you plan on rendering movies from Unreal Engine, project size, performance, all of this is going to impact you very heavily. If you're generating missing collision on every mesh that you import, you're adding a lot of data to your project and increasing your project size. And not everything needs collision. So it's better to often just generate it as you need it, and instead of generating it from the mesh on every import. Scrolling down, I'm also going to turn off generate light map UVs in this particular case because I am looking to move to UEFN or I'm looking to render. I'm not necessarily going to be baking lighting. I can always generate UVs another time. If I had a lot of different meshes as part of that one mesh, I would turn on combine meshes because my material IDs will still be intact. as I set them up correctly in Maya. I changed normal import method to import normals and tangents. Just seems to get the best rendering result. Now, I neglected to bring my Unreal Mannequin into my export scene. So this is going to come in really, really small unless I scale it up. So I'm going to scale that up by 10 because Maya is much smaller than Unreal. The next thing I'm going to do is under material, I'm going to say do not search and do not create materials. Again, I'll turn off import textures. I want to set up my materials myself in Unreal to make sure that they're set up correctly. And that, when I'm working with clean code, I've controlled the naming convention, etc. It may feel faster and easier to do it, to bring in your materials from your 3D program, but it often creates more problems than you need at the end of the pipeline. So we'll import that. Okay, and here is our funky cool mesh. Now, the cool thing is, it does not seem to have the normals errors on the tips of each feather that it did in Maya. So I don't think there's going to be as much use for the other smooth asset as I had previously thought. But especially as my quote unquote lower res asset still has 741, 387 triangles. That's a lot of triangles. We're going to go straight into reducing the size of this. So this is coming in at 17.81 megabytes. That's when you're talking, and when we're looking at rendering and we're looking at UEFN, every byte counts. That's a lot of, that's going to take up a lot of disk space that it does not need to, because I will show you in a moment that reducing the size of this mesh, or reducing the complexity of this mesh, is going to have a negligible impact on the quality of the render. So one thing I want to point out just really quickly is on the material slots here, because I set up the material IDs in Maya before exporting, I have 2 material slots, just like I had 2 materials. And the slot name is M1 and M2. It has inherited the material name I had in Maya. This makes your life much easier when you are going to go through and set up your materials, etc. Now, I do not have Nanite set up automatically. Again, same reason. I don't want to be bringing Nanite in unless I need it. And not every project does. UEFN in particular, you want to make Nanite a conscious decision. And if you're bringing in maximum Nanite with every mesh, you will be in your UEFN project reducing your Nanite settings at the end of the project for hundreds of assets. Just an absolute pain. So what we can do, however, right now is we can reduce our triangles and vertices and reduce the estimated compressed disk size of this asset before sending it to UEFN. So under LOD 0 here in the right-hand screen, what we're playing with is called reduction settings. And I'm going to reduce, I'm going to actually start with, I'm going to drop right down to 25%. I want 25% of the existing triangles. The thing to watch, so when I'm doing a reduction, is I'm watching the edges of this mesh, and I'm just trying to see if it's going to dramatically change. Because if it doesn't dramatically change, I can keep going lower. If it does dramatically change and the silhouette is negatively affected, then I can go higher. So I'm just going to apply changes, watch the corner of the mesh, or watch one of these feathers. I'll hit apply changes. Let that go through its operation. Okay, so we have reduced our disk size from 17 megabytes down to 4. Reduce our triangles significantly, and there's not a significant change in the silhouette. I'm going to get a bit aggressive and watch out, world, here I come. I'm going to drop down to 10% triangles. Sometimes you'll notice that round numbers like 10, for some strange reason, Unreal gets a bit funny and is like, well, surely you meant 9.999 to the power of 1,000. a quick solution to that is just make it 11. Let's hit apply changes. And while we've got a little bit of hardness being introduced on the edges of these feathers, I'm now down to 2.5 megabytes, 81,000 triangles, and I'm going to keep going. I think I can go down even further, to be completely honest. And what's very exciting about the reduction settings is I can go back up. It's not permanent. I'm going to go down to 5%. And when you look at that, the integrity of the model is still there. I'm down to 1.4 megabytes. It's still a bunch of vertices. But if this were, say, going to be on the side of a building that has been blasted with some sort of alien technology and it's a big feature hero piece, sure, I will get away happily bring my 41,000 vertices in. But if this is going to be if this is going to be just on screen for a few seconds, or if it's a kind of a cool theme, but it's a relatively minor asset, I would actually take this much further in terms of optimization and go so far as to produce a low poly cage and generate a normal map for this, take it into Substance and pack my textures, etc. All of which is absolutely material for another video. But this, however, covers all the steps I go through when conditioning assets from third-party programs to bring into Unreal Engine. And from here, I can take this over to UEFN. Look at this beauty. Check him out. He looks fine for being 5% of his standard polygons. And if I wanted to send this over to UEFN now, if I was doing this just for an individual asset, I would right click on the asset, go Asset Actions, Migrate. Yes, I can save my entitled scene. That's fine. That's fine. And I will show you where you would be migrating that to. So in your UEFN folder, you're going to be migrating to the content folder of your UEFN project, which if you're used to working in Unreal is actually kind of hard to find. So I will walk you through the process of finding that. And I am now looking for a UEFN project to migrate this over. Let's say I'm sending it to my experiments project, and the content folder, so it has to go into the content folder. You go into plugins, the name of the project, and its content there. Nothing inside. It's got to be content. And then you would, I go select folder, and it's going to migrate that across. And that asset will be available to me over on the UEFN side. A little bit more on migrating assets from Unreal Engine to UEFN, including how to migrate entire levels over and what can come across and what doesn't, will be in the next video. All right. Thank you so much.